class we were working on the motion activity, and we weren't quite able to wrap that up. So I'm going to see if I can go through and get this set up for you guys and kind of lead into this whole idea of the difference between instantaneous velocity and average velocity. So to do that, let me pull up my iPad real quick and work through this. All right, to begin with, like I said, the file was the motion activity. So within that motion activity, what we were doing is going through and graphing, creating a table, etc. for this particular relationship. And we're seeing that time is our independent variable. So in other words, that's going to be our x value. And position is going to be our y value, or our dependent variable. With that in mind, as you went through, you were able to plug this equation into your calculator. So you plug that equation into your calculator, and when you did that, then the idea was that you were going to use one row and be in charge of one interval. And in that process of looking for those intervals, you were going to go and find the average velocity. So you could do that with a calculator, you could do it with a graph, you could use it, do it by going and plugging it into your equation. Either way is fine. The idea, though, is that as you're working through this, you're able to go through and find your change in time and find your change in position. So just kind of walking through this for those of you that need a little bit of extra support. As you're working through this, the idea is that you're going to plug in whatever time value it asks you for. So it could be 3 seconds. And when you plug in that 3-second time into your equation, you're able to get your position value. And by doing that, you're able to figure out your position value at the beginning of your time interval and at the end of your time interval. And then you use those values to find your displacement. And then you take your displacement, divide it by your time to get your velocity. And we were using different colors to represent that. So, and in addition, when you were graphing it, you're able to graph your relationship here and graph your function. And when you did that, you created a graph that looks something like this. Now, and I have this kind of written on here already, what you're then going to do is with this particular graph, you're using this graph to be able to go and create an average velocity. And the way in which you're creating an average velocity is by going through this time interval. So for me, it's going from 3 seconds to 8 seconds. So between 3 seconds and 8 seconds, our average velocity is going to be the slope of that secant. That secant line is just connecting those 2 points, the 3-second point and the position at 3 seconds and the position at 8 seconds. And that secant line, that slope of that particular line is going to be, in this case, 77.75 meters per second. And you can see that now on this graph, I went through and I did the same thing. But what you're noticing is that as I'm going through this, I'm narrowing the time interval for that particular average velocity. And by doing that, you can see that originally I went over and I have this yellow line. Then the line becomes green, and you can see that that time interval causes the average velocity to change. And I did the same thing for the red. The red was just a little bit larger, a little smaller time interval. And you can see that during that time, it causes my average velocity to change. And in the process of doing this, as we keep on going and take smaller and smaller intervals, we eventually get down to our very, 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 very tiny interval, which is, I believe, was 0.1 second interval, which is the blue one. And with that one, it created this average velocity of 25.9. Now, as we get to smaller and smaller, and we start to create an even smaller time interval, if we take that to the extreme, what we end up getting is this tangent line. And let me bring that back up onto the original graph. The tangent line would be looking something like this. That tangent line will give you the actual speed, or the instantaneous speed, instantaneous velocity in this case, of that particular time location, that point in time. So in other words, what is the velocity of the vehicle at that one particular point in time? And you can see that that's different than the average time, the average velocity that we've been experiencing. So when we're talking about average velocity, we're looking at the velocity over a time interval. Okay, and in other words, looking at the secant line, the slope of that secant line. And when we're talking about instantaneous velocity, we're looking at the time over one specific point in time, one snapshot in time, and finding the velocity by going and taking the tangent of, or in other words, the slope of that tangent for this particular curve. So, once again, when we're looking at this, just kind of going back to our flashcards. If we're looking at our average velocity, an average velocity is going to look at the velocity over that period, which if the velocity is changing, it means that it's not an accurate representation of a single point in time, the velocity at that single point. It's looking at a cumulative effect of the velocity over that time. So with that average velocity, what you're doing again is you're taking one point in time, another point in time, and over that time interval, you're finding the slope over that time interval. So in other words, this average velocity, this slope value, this rise over our run, is going to be equal to the slope of our secant on the position versus time graph. Average velocity is just looking at, like I said, a combination of the effect of the position and velocity over that time interval. Now, if we're looking at the instantaneous velocity, the velocity at a certain instant in time or point in time, then we want to figure out the velocity at one particular location. In other words, if we're looking at this particular time or that particular location, to find that the speed or the velocity of that particular point, we're looking at the tangent of that particular curve. In other words, the line that is going to be, in this case, the slope is going to be of that tangent line, is going to be what we'll observe as being the velocity at that one instant. So when we're looking over here and we're looking at this idea of average velocity, you can see that average velocity isn't necessarily accurately representing the velocity at each of those individual points. But when we look at an instantaneous velocity, that's representing the actual velocity at that one snapshot point in time. Now, also I want to bring up and point out that there's a WebAssign problem number 12 helpful hint that I posted on WebAssign. So if you'd like to go on to WebAssign, that's posted. Otherwise, you can see this particular image. We're looking at the rabbit and the hare and looking at how that all works. So if you want to take a look at some of these hints, it's also posted on WebAssign. You want to wrap that up for tomorrow. Thank you. Let me know if you have any questions.